Wood is widely used in construction. The advantages of wooden constructions are high strength, low weight, easy way of manufacturing structure, restoration of materials, and environmental fitness and high aesthetic characteristic. However, wood has its drawbacks. These disadvantages include easy damage to structure by natural pests, its fungi and insects, low fire resistance and high flexibility. In the modern world, impregnation wood with antiseptic and fire retardants allows you to get rid of pests and ensure the necessary fire resistance. However, increasing stiffness or decreasing flexibility is an actual problem. It is possible to solve the problem of increasing the rigidity of bending elements with the help of reinforcement with rigid materials. We propose the reinforcement of plywood panels with the help of the steel reinforcements and carbon type. Regardless of the problems of this work, one should not forget about the basic principles of construction, namely ensuring their strength, rigidity, reliability, and economy. Ensuring the strength of structure is performed by calculation plywood panels for various types of external influence. The rigidity of structure is ensured by appropriate analysis of deflections, displacements, movements of parts of wood elements, and reliability, which is ensured by mathematical modeling of work. The main task of designing plywood panel is to ensure its economy, because this is the consequence for the further efficient use of material and resources. Therefore, this article describes the construction of a plywood panel using modern method of modeling their work. To design plywood panel, it's necessary to determine stress deformed state. Slide 4 shows the stress deformed state in the central part of the panel, where the greatest bending moment occurs. The slide also shows the system of equilibrium equation and all necessary equations. The design of plywood panel should be based on the stiffness strength of the structure. To carry out the design, it is necessary to determine the strength of the panel at the maximum bending moment, as well as under the action of the shear stresses. Slide 5 shows the algorithm for determining the dependence of the curvature on the moment. By substitution the curve and gradually increasing the maximum bending moment is determined, which is actually to the failure of the structure. Also, the graphs of the moment to curvature can be used to determine the shear stresses and the deflection of the structure. To prevent shearing along the fibers, the stress strain state was shown and the equilibrium equation was written. To determine shear stress, it's enough to determine the change in forces action into adjustment across section. The equation for determining the efforts are written on slide 7. The determinant of deflection, we use already predefined graphs of the moment of curvature and use such sequences. First, it's necessary to determine the change in curvature along the length of the beam, then to determine the angles of rotation of each section. But last of all, it's necessary to determine the deflection in the section. After assuming this deflection using the boundary condition, we will get the total deflection of plywood panel. The basic formula are shown on slide 8. And conclusion of our reports, a deformation method for theoretical and mathematical modeling and calculation of plywood panels with composite reformers is proposed. Deformation method is part of the theoretical foundation for modeling the work of elastic plastic elements. And taking into account the stress-deformed state of plywood panel will allow predicting the work of wood during its manufacture, operation, and failure. That's all about our report. Thank you for attention. And can you ask questions about our report?
Okay, Petro, thank you very much for this very interesting presentation.